Find them and write down exactly what we just finished doing. So to start, let's create our little grid. You're going to do lots of your little grids. 3 times 4, we talked about that. So with our grid, we would have 3 on one side and 4 on the other side. And the area on the inside is the answer. So we're looking at area models, length times width for a rectangle. And again, it's 3 groups of 4. There's 1 group, 2 groups in the middle, and the bottom row would be our third and final group. So when you're stuck on these, this can help you on your quiz or test get the right answer. So this here, 3 times x plus 2, on our next question, what does that stand for? 3 groups of x plus 2. Now again, I didn't mention this, but it doesn't matter which one you have on the top or the side. Okay, generally we like to kind of write it as it's written for our symbols, and so we put a 3 on the left and an x plus 2 on the top. But you can totally interchange those. Okay. So we have 3 groups of x plus 2. There's 1 group, and there's 3 more. Okay, so I want you to finish that off, and then try and complete the multiplication statement. Okay. We wrote those on the board. Try one by yourself. Go. Okay, so there's the second group and the final third group. So the multiplication statement, we have 3 times x plus 2, and that equals 3x plus 6. That's what we have in our answer. Now, it's good and helpful to know what we call this part of the multiplication statement. Sorry, the 2 separate parts. The part on the left, those are our factors. And what would be the answer? What do we call the answer to multiplication? Product. Okay. We use those words a little bit in grade 9, but that vocab's all over the place in grade 10. Okay. Okay, number 2. Go ahead, draw it. Put 2 on one side and 2x minus 1 on the other side. Come up with your answer, write your statement. Don't forget to shade in your negative ones, okay? So when drawing these, no color is positive, shade is negative. Who has the multiplication statement? Xander? Minus 2. Good. Hands up if you got that. All right. Okay, so we've done a few of these. Thumbs up, down in the middle. Okay, good. So a couple harder ones. Instead of just a number in front, now we have a variable as well. So we have the letter x. So now we have 2x times x plus 3. Okay. So we talked about how to arrange the 2x. They must be touching the side. And okay, and then the x plus 3 must be touching the side as well. Okay. Do you guys want me to show you how to cheat? I mean, show me something to look at? Better choose my words carefully. Okay. I know that this is the rectangle that's going to be formed, because that's the entire length and the width. So I can actually trace the outline to start with if you want. Okay, so you can trace the outline to start with. If you watch me drawings or have watched, that's how I start. Okay, so something you might want to do, help you with your arrangements, and then I can trace my lines as well. Okay, so try this one, go ahead, finish it. Okay, so some people are working on the next one already, I see. There we go. So altogether then we have 2x squared plus 6x. Notice how the 2x multiplies by the x as well as the plus 3. So there's two parts to that multiplication. We have two different terms, an x squared term and an x term. Can we put those together at all? Can we add those? No, we can't. When you say cats plus dogs equals cats plus dogs, we don't get the cat dog happening. All right. Next one, go ahead, finish it. Some people start already. Watch out for your negative sign and your shading. Go. You done already? Okay, final answer. Who's got it? Taylor? 6x squared minus 6x. Hands up if you got that. Awesome. Again, two parts. We have the x squared developing from 3x times 2x, and we have the 3x times the negative 2 part. Okay, two parts to your multiplication. So, how many people want to draw 14x times 28x? Oh, you want to? No, you don't. So we got to go to our symbols. Now, what we do with our symbols is we use our arrows to help show the multiplication. Okay, so we can go 9x times 3x, and we've done that before in our exponents. What happens with your exponents? X times x? X times x? Yeah, we get our squared part. Okay, so x times x, the exponents are 1 and 1. And so the base stays as x, that's what stays the same. But we get 1 plus 1. That's why we're getting this x squared. Okay, so we could see that with our tile pieces and the area. But now we have to be super careful of that when we go with outer tile pieces. Now what's 9 times 3? 27. So imagine having to draw 27x squareds. That would be a lot. We don't want to do that. And I use my arrows. 9x times plus 5. What would that be? 9 times 5? 45 x's. Can we add those together at all? No. All right. Try the next one. 7x times 5x. And then 7x times minus 6. Watch your signs. Okay, you got to include that negative sign with the 6. What do we have? Negative 42x. Okay, thumbs up, thumbs down in the middle. What would you say? Vote, please. Okay. So we're going to go a little bit harder. And the only thing that's a little bit harder is our exponents get higher. But when we multiply exponents like x squared times x, what do? What do we do with the exponents? Add them up. So we get x cubed. Okay, we can't, well, we could draw a cube, but we can't actually have that shape. That's why we have to go to the symbols. All right, so do your multiplications, 2 multiplications. 4 times 2. X squared times x gives us x cubed. And what about 4x squared times 3? So that's like 3 groups of 4x squared. 12x squared. Okay? So we multiply our coefficients, the numbers in front. Okay, any questions? Meaty. Well, you have cubes plus squares. How many cubes do you have? How many squares do you have? Okay, if you put them together, what are you going to make? A cube square? Right? Well, it's like cats and dogs again. The exponents are different. Okay, so that means they're different terms. You can't put them together. And that's a very good question because that happens a lot by mistake. Okay, different exponents, different terms. Different exponents, different terms. Okay, that's really important. Any other questions? Okay. All right. Next one. Now we're going to go a little bit further. So we're going to still do our multiplication. This time there's a negative sign which we have to include. Multiply it in. Okay. And then we have another multiplication. A plus 3x. Multiply it in. Okay. So I'm using 2 different colors. First one's green. Do that multiplication. And then do the second one. And then just stop. Unless you think you're an expert, but I'd stop. Should be this big X is the same. That's the math program I was using. Okay, so imagine that big X is small x. Okay. Minus 15x. Good job. Thanks for catching that. Taylor?
Why would it be 15x? Wouldn't it just be 15 or?
Well, we still have the x with the 3, so it's basically it's 3x times negative 5, or negative 5 groups of 3x. Okay, so if you're keeping in mind with that, how many groups of x, you're going to end up with the x's as well. All right. What should we do now? Any ideas? Meaty. Yeah, see, now you can do it, right? So now tell me how many x squareds there are. Tell me how many x's there are all together. Go for it. So what do you get?
Negative 2x squared minus 21.
Minus 21x. Good job. How many people got that? Hands up. Okay, that's going to be by far the hardest question you're going to see in grade 9. Okay, so you're going to have to do 2 things at once. Multiply in, and after you multiply, then collect like terms, if there are like terms. That's a little bit of a hint for the next question. Go for it. Number 5. Okay, multiply in, collect like terms. Go. If there are like terms to collect. Okay, so multiply in 20x squared minus 12x. Over here, make sure you include the negative sign, minus 6x minus 8. Now, the 20x squareds, there's 20x squareds. Your constant's negative 8. How many x's in total? Negative 18. So you got to be careful. Here we include the negative sign. So it's not 12 minus 6. It's negative 12 minus 6. Okay? Super careful with that. That's a bit of a tricky one, wasn't it? No, some say yes. I say yes. Okay? All right. Multiplication. Thumbs up, thumbs down in the middle. Okay, turn it over. What's the opposite of multiplication? Division. All right, the tiles can help us with that. And I'll be honest with you, drawing the tiles can be a little bit weird because you know multiplication. Okay. So what we have to do is we have to arrange 2x plus 6 on the inside, but somehow we have to arrange it with the 2. So we're dividing it into 2. So keep in mind your tile arrangements. Make sure you try and split everything into 2 equal groups. See what you can do. Just play around a bit if you want. Okay, so you have to draw this. Okay, remember you have to draw it. Somehow you have your 2x plus 6 fitting in that spot. It's got to make a rectangle. Okay, so your 2x should go in this direction, lengthwise. Okay, now you have to fit in your plus 6. Divide 6 into 2 equal groups. Okay, Blades, what you need to do is draw it, not write it, right? You're trying to do the writing part? Okay. There we go. So there's the plus 6. So where are we going to find your answer? On the top, the length of the top of the rectangle. So here we have an x that fits over top and a plus 3. So we're dividing into 2 equal groups, and we get, as our statement, x plus 3. Okay, x plus 3. So the division statement down below the whole thing would be 2x plus 6 divided by 2 equals x plus 3. What do we call x plus 3? The answer to a division question? You don't use it too often. Quotient. Yeah. T-I-E-N-T, quotient. Okay, so that would be your quotient. In your textbook, they'll use that word. They'll say, find the quotient. What do you think they mean by find the quotient? Divide, right? So you're doing your division to find that. Okay, a harder one, x squareds now. Okay, x squareds. Now somehow you have to arrange it into 5x groups. So there's 1, 2, don't write too big, 3, 4, 5x groups. And now you have to arrange inside 10x squareds and 5x's. Bit of a challenge for you. Give it a shot. So, how many x squareds would I have in this group? 5. Okay, so you got to match up your 5x's, 5x squareds. But I have 10, so where should I put the other 5? Next to it, okay? And then my 5x's, just tack on beside. So what's the answer? What's up top? Not 2x squared. Not 2x cubed. What's the length of the top? 2x plus 1. Okay, so this equals 2x plus 1. So what we're really doing is we're doing 2 divisions. We're dividing the first term by 5x squared, and we're also dividing the second term by 5x. So I said 5x. 10x squared divided by 5x, and 5x divided by 5x. Okay. Questions? Okay, so your division statement, well, I wrote it up top, I'll write it again. 10x squared plus 5x, and you're dividing each of them by 5x. That gives us 2x plus 1. Okay. Questions?
Is it 2x squared plus 1 or 2x?
Just 2x. That's what we drew up top. Okay? You're just telling me the length of it. All right? Now, without tiles, okay, we're going to go without tiles. We have to use our exponent rules. So we're going to get something like x cubed divided by x. Using our exponent rules, that would be 3 minus 1, which gives us x squared. So we have to subtract. Okay. Now without tiles, it's helpful to split this into two separate divisions. So the first thing you should do is rewrite this as 12x squared divided by 3x minus 15x divided into 3x. This is helpful for those that want to take pre-calculus 11. Okay, because sometimes you can only divide half of the statement. So we're breaking the question to two separate divisions. On the left, what's 12 divided by 3? 4. X squared divided by x. X exponent 1. We subtract the exponents. And what's 15 divided by 3? 5. X divided by x. Well, it'd be 1. Okay, so it'd be 5 times 1. So that's our answer. Okay, our answer is 4x minus 5. There's the answer to the first part, answer to the second part. Okay. Question number 2. How many separate divisions will there be? 3. Go ahead, write them down. I think you wasted half the apple there. Krisha, what's the answer? Just for the first part, first term. 5x, x squared, good. Second one, plus 2x. Whoops, I can't write a 2. And what's the last one? Plus 3. Okay, the x divided by x. This x divided by x equals x exponent 0. And that equals 1. Okay, that's how we're getting that last division part. All right, any questions? Niti. Okay, well, when you're dividing x cubed divided by x, what do we do with exponents when we divide? Subtract. This is an exponent 1, so it'll be 3 minus 1 x squared. Okay, so you're reducing it by 1 numbers, or 2, depending on what you're dividing by. Okay, but usually for grade 9, we keep it simple. Okay. Next one, go for it. Number 3, all by yourself. See what you can do. Kyle, first division. 2x squared. Xander, second division. Minus 4x. Good job on the negative sign. Ishan? Plus 6. Good. So there's your answer. There's your polynomial. All right. Next one. Please change this to a 14. That should be a 14. Okay, so we have another typo here. Then we have 14, 28, and 7. We have x cubed, x squared, and x. Can anyone think about, what can we divide them all by? Any ideas? 7x. So in grade 10, that's what we do, is you have to guess and tell me what to divide it by. We call that the GCF, or greatest common factor. Okay, so we don't need to know that for grade 9, but that's kind of what we do next year. Okay, so divide this whole thing by 7x. Make sure you change the front one to a 14. Okay, so the front should be a 14. Go ahead and do your division. Okay. Noel, what's the first division? Middle division. Christian. 4. What with the letters? Good. And the last division? Let's go, Emma. +1. Okay, so don't forget that +1 part. That's an important one. All right. So let's have a look at this. Adding, subtracting, multiplying, dividing. So we're going to add and subtract. What are some similarities and differences? Okay. Well, looking at the algebra tiles for adding and subtracting, you're not making new terms. Okay, so you're just going to tell me how many x's there are, how many squares there are, how many one tiles there are. But for multiplying and dividing, you are making new terms. So for example, if we have x times x, you are making x squared. If you have x times 1, you're making an x. So those are new terms. Or dividing, you're making new terms. But what they have in similar, or in similarity, is that you cannot combine unlike terms. So 3x squared plus 2x equals 3x squared plus 2x. You can't put those together. Okay. Any questions?